Students, welcome to Divine Public School. I'm your science teacher. We are learning chapter 11, the human eye and the colorful world. Now, yesterday we saw the defect of vision in a human eye. In that, we learned how does a ray, right, get refracted and it will meet on retina. So when it meet on retina, you can see a clear vision. That is a normal eye. But if it meet in front of retina, that was myopia, or if it meet behind the retina, that is hypermetropia, that was an error which can be corrected with the help of a lenses. Myopia can be corrected with a concave lens, and hypermetropia can be corrected with a convex lens. Then the last part is presbyopia, where the person cannot able to see near and the far object both clearly, right? And over there we use bifocal lens. One more defect is there, cataract, right? Over there on your pupil there is a white layer come on your pupil. Okay, when a white layer come on your pupil, it can be only corrected with a surgical intervention, right? In our language we call it motio, right? So cataract, just for the information. There's one more error comes in our eye. There's a at that point of time, the in the middle, the white layer comes. Okay, the white layer, if it depend upon, if the white layer is little, then the person can see partially, and the other person is whitey, he can see. If the layer is so thick that one eye he cannot see, or he or she cannot see anything, he is complete blind person, which can be only corrected with a surgical intervention. Okay, now we are going to see today refraction of light through a prism. Now that's also one of the important phenomena. In the previous chapter we have learned, when a light falls on a rectangular glass slab, what happens is the image appears to be raised up, right? We have seen that. Now over there, that was a flat surface. Now what if we incline the surface, right, and make it a prism? Okay, once we meet, definitely going to show you all such experiments. So in the prism, right, it looks like this. See, now prism have it has two triangular bases and three rectangular lateral surfaces. Understand this thing. So you have to put your prism in a way that it has two triangular, your prism has two triangular bases and three rectangular lateral surfaces. Okay, so then this is the activity 11.1. We are doing activities here, and you should also do all the activities of the chapter, because normally they ask questions from activity also. Okay, so what we are saying is that this is your prism. Okay, now let me show you the activity, what it actually says. See, so this is your prism. Let me draw. Okay, now this is your prism, and we name it as ABC. We name it as ABC. Now this is quite an interesting phenomena. This will also tells you how does a refraction work so better here, right? Now this is our incident. This is our incident light. So when a light falls, this is our incident light. Okay, So that's your incident ray, right? Incident light. So we name incident light as PQ. Okay, we name incident light as PQ. Fine. Now, at what angle the light is incident? In order to understand that, in what angle, this is not the angle of incidence, okay? No. For that, in order to find the angle of incidence, you have to draw a normal at the point of incidence. Remember, over there also we used to draw a normal, right? How? See, I'll show you again. Remember the angle of incidence we used to put? That this is your surface, we used to draw a normal, and then when an incident ray come, this is your angle of incidence. Remember? The same thing happened here also. Yes. The rule doesn't change. So here also the angle of incidence remains the same. What we have to do is we have to draw the normal. So we have to draw a normal here. Let me draw a normal. So this is your normal. Okay. So this is your normal and this is your angle of incidence. So I'll write it I. Okay. Now what happens is, what they're trying to tell you is that when a ray incident, and we give that name also, we give it as E. Okay, so I'll name this as E. This is your 90 degree and that was your angle of incidence. Now when a light, so how you're saying, how you're going to write down, let the incident ray PQ incident at point E on surface AB. After incident on surface AB, what happened? The medium changes. You know, this is air and that was glass. So what happened is it bend, right? That it is going from rare to dense medium. So it bend towards the normal, right? It bend towards the normal. Remember, the rules remains the same. So it bend towards the normal. Okay. So this is, it bend towards the normal. Now, this is your point F. Okay. Now what happens is, again the light is incident on surface and again the medium changes. So medium changes. Now it is going from, it move rare to dense to rare. It is moving, it going from, so it bends away from the normal. So here, right? So I'll name this again as RS. Now what is your so this ray we call as incident ray, right? We call as incident ray. This is your refracted ray. And what do you call this ray? RS. We call it as emergent ray. Emergent, right? I already discussed that thing in our rectangular glass slide. So incident ray, refracted ray, and emergent ray. Now what you have to do is incident ray, right? Now what is your angle of emergence? So in order to draw an angle of emergence, what we have to do is we again have to draw a normal. So I'll draw a normal here. So this is my 90-degree angle. So this is my 90-degree angle. And this is my angle of emergence. So I'll write down as E. Okay, so hope you are getting what I'm trying to say. Now, what does an experiment tells you? What do they do is they used to see, they used to put, they used to put two pin. You remember the pin, the thumb pins, not that big one, not exactly the thumb pins, the small one. So that pin they used to put it here at P and at Q, and a person will be here, right? A person will see from this side, right? And when they try to see this pin, they used to put two more pins at R and S. While looking in the prism, they used to put R and S. Now, when what do they observe? They see all four pins in one line, P, Q, R, S. Surprise! Look at the front view. If you see the front view, you see PQRS is not in one line, right? You see the PQRS is not in one line. But when you see from the prism on the other side, you see all four pins are in the same line. Exactly. Why does it happen? Because of refraction. Because of refraction. That's our experiment. Okay. So that is what they are trying to tell you. That when you try to see, it looks like this. Okay. Let me show you it on our textbook. See. Fix a white paper, right, on a drawing board using drawing pins. Now you have to take prism and you have to trace the triangular surface, because when you remove this, you should look a picture as what we have drawn. So put a triangular surface at the bottom and keep a rectangular surface on the sideways. Draw it and remove the prism. Now uh, draw 90-degree angle and draw an incident ray and put two pins on it, P and Q. Right, now put the prism again, and from the other side you see and put R and S such that they all comes in the same line, right? See, fix 2 points and now remove the pins, right? And note PQRS. Okay, now remove your prism and draw a normal MF 90-degree and all. Okay, so this is what this says. Now I'll tell you what are the other things. I already told you what is an angle of incident ray, refracted ray, emergent ray. Right, now there are two, three more things. Now this angle is called angle of prism, right? This is called angle of prism. And remember, the angle of prism is always 60 degree. Okay, it is always 60 degree, right? It is an equilateral triangle. Now what they are trying to tell you is, if you extend these two lines, incident ray and emergent ray, see this one, if you extend these two lines, incident ray, right, and emergent ray, they meet at one point here. Okay, they meet at one point here. This angle is called angle of deviation. What do you mean by angle of deviation? It's like the ray is going straight, right? So if you don't consider at two places it is getting bent, they just simply explain you that the incident ray get deviated at one point and goes on the other side. So this is called angle of deviation. Angle of deviation. Okay, let's see. So angle D, as what I showed you, when you extend, you have to draw it a dotted line. So when you draw it a dotted line, it is meeting at D, right? We call it as angle of deviation. E, angle of emergence. R, angle of refraction. I, angle of incidence. Okay, so that is all about it. This is an experiment they normally used to ask in our exam, that explain refraction of light through a prism. So at that point of time you have to write activity 11.1. Make sure you put all your efforts to understand what I'm trying to say. Okay, so tomorrow we are going to see dispersion of white light, its experiment, and the rainbow. Okay, fine, I'll see you tomorrow. Till then, bye, take care.